All right, let's continue into 3.5 OWASP Top 10 API threats, starting with API1, Broken Object Level Authorization. I'll explain it in detail, then anchor it with real-world cases like the T-Mobile breaches, where attackers exploited direct object references. 3.5 OWASP Top 10 API Threats. The OWASP Top 10 for APIs is the industry's go-to reference for the most dangerous and widespread API vulnerabilities. It's not theoretical. Each of these categories has been observed in real-world breaches that cost companies millions, leaked sensitive data, and eroded customer trust. Let's walk through them one by one, starting with the number one risk, broken object level authorization. HAHARD API1, broken object level authorization. At its heart, BOLA happens when an API fails to check whether a user is actually allowed to access a specific object. The API might verify that the user is authenticated, but it doesn't validate ownership of the resource being requested. That's why this is often called an IDOR, insecure direct object reference. Here's a simple example. Imagine an API endpoint. You can see the code in our conversation history. If Alice is logged in and changes 13 to 124 and the API returns Bob's profile, that's broken object level authorization. The system authenticated Alice, but it never checked that Alice is authorized to access Bob's data. Real world case. T-Mobile breaches. T-Mobile has suffered multiple breaches tied to weak API authorization controls. In one 2021 incident, attackers exploited an API that allowed querying customer records by phone number. The API validated that the caller was authenticated, but it didn't validate whether the caller had permission to look up any customer. As a result, attackers enumerated millions of customer records, including names, dates of birth, driver's license numbers, and social security numbers. The breach wasn't due to missing authentication, it was due to missing object-level checks. The API assumed that once you were in, you could query whatever you wanted. That's the essence of BOLA. Other examples, Instagram 2019. Security researchers discovered they could exploit a user ID parameter in Instagram's private API to access private account details of users they didn't follow. The API authenticated the request but failed to check authorization against the target object. Klarna. A flaw in Klarna's API allowed logged-in users to see the personal details and order history of other customers simply by modifying object identifiers in requests. Why BOLA is so common. APIs expose object identifiers directly, user IDs, account numbers, order IDs. Developers often assume authentication alone is enough, forgetting that authorization is object-specific. This is especially common in microservices, where one service trusts another to enforce access rules, but no service actually validates ownership. Mitigation strategies. 1. Enforce object ownership checks at the API level. Every time a request references an object, the system must confirm, does this user have the right to access this specific object? 2. Use indirect identifiers where possible. Instead of exposing sequential IDs like 123 or 124, use opaque IDs like UUIDs. This doesn't replace authorization checks, but it makes guessing harder. 3. Centralize authorization logic. Don't leave it to individual services to implement their own checks inconsistently. Use frameworks or policy engines like OPA to enforce rules uniformly. 4. Test for BOLA explicitly. During API security testing, always try changing object IDs to see if data leakage occurs. Tools like OWASP Zap can help automate these tests. Lab exercise. Set up a simple API that returns user profiles based on user ID. Authenticate as Alice and try changing the ID to Bob's. Without proper authorization checks, the system will happily return Bob's data. Now add a check that enforces user ID equals session user ID. Try again and watch the unauthorized request fail. This exercise shows how trivial BOLA exploits can be and why they're so devastating if overlooked. The lesson is this: broken object level authorization isn't exotic. It's one of the simplest attacks an adversary can attempt, just changing an ID, yet it's behind some of the biggest breaches in recent years. Always remember, authentication alone is not enough. Every object reference in an API must be checked against the user's authorization to access it. Do you want me to continue into API2 broken authentication with case studies like Twitter's leaked API tokens and weak session management in mobile apps?